Hello, I have this problem here that states a rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 27 minus x squared. Now the problem asks us to find the dimensions of a rectangle that has the largest possible area. And we want to list the width and length of the rectangle and list the largest area of this rectangle. So first step that I would do is go ahead and draw the parabola. We know the parabola has a vertice at 27 and the parabola faces downward because of the negative in front of the x squared. So we have an infinite number of ways to draw rectangles that are inscribed in this parabola with a base on the x-axis and corners on the parabola itself. So which one gives us the largest area? So the red rectangle that I drew here, we know the top right corner, this point, intersects with the parabola. And we can write out the coordinate as x, y. Now, the x is just from the distance from the y-axis to that point, and the y is the height, or the y of that point. Now, what is that on the rectangle? That's half of the base and the full height of the rectangle. So that means that we have the base, which is a negative x on this side and a positive x on this side. We know the length of the base would be the x plus x, which is just 2x, right? And the height of this rectangle is y. So what's the height? The height goes all the way up to the parabola. In the parabola, the equation is given as 27 minus x squared. So the height is just 27 minus x squared. Now finding the area of this rectangle, we know it's base times height. So the base we already discussed is 2x, and then the height is the parabola itself. So the base times height is 27 minus x squared. 2x times 27 minus x squared. So how do we maximize the area of this rectangle? So here we have the equation. Now maximizing any function, all we need to do is take the derivative of that function. So the derivative of this area with respect to x, we get the derivative of this function. So if we distribute the 2x times 27 is 54x, right? But the derivative of 54x is just 54, so I'll write 54. Now distribute the 2x to minus x squared, we get 2x cubed. So what's the derivative of 2x cubed? Bring the 3 down in front, so 2 times 3 is 6, and then subtract 1 from the x cubed. So we get 6x squared. Now, if we set this equal to 0, that will maximize this equation. So solving for x with this equation, we'll get x is equal to plus or minus 3. We move the 54 over. 54 divided by 6 is 9, and then square root the 9, we get 3. And don't forget your plus and minus. Now to get the area, we just plug the 3 back into this equation. So 3 into this x and this x will give us an area of 108. Now the base of the rectangle is just this 2x portion. So if we plug in 3 into the 2x, we'll get the base is equal to 6. And same thing with the height. The height is going to be equal to, plug the 3 into the height portion, which is the 27 minus x squared. So 27 minus 3 squared, 27 minus 9, we get 18.